Cool. All right, we're getting some other people filtering in here. Still no one from core, but maybe we can get going. Um, Although Josh and Sage, especially, were the ones that wanted to talk about the autoscaler, so we should at least wait for them for that. But in the meantime, there's actually a surprisingly short number of PRs to talk about here, given that it's been about a month since we last had this meeting. There was a PR for parallel crush calculations for the balancer. I think that still needs to be reviewed. And then there was another balancer PR for eliminate usage of MS infrastructure for upmap mode. Sage looked at that, I think. A couple closed. Another balancer one. I think there were a couple of different balancer PRs for improving performance when people are hitting like issues in the manager related to this. That's probably one of them. Adam's modification of my double caching PR on top of his sharding PR closed by Stalebot. I think that's fine for now. I suspect that both my original PR and his updated PR both will need to be redone based on all of his newest work. So we'll just let that sit for now. And then once we actually merge the sharding, RocksDB sharding PR, then I'll go back and take both my original one and his updated one and kind of figure out what remains that needs to be done to get it in. All right, and then there was another one from Roman to increase messenger IOPS. Greg, I think you looked at that a while back, but I'm not sure if he ever did anything with it or if we even were able to verify what was being done. Do you remember that at all?
No.
Okay. Well, I don't think he's followed up on it if I remember right. So, yeah, we'll see. Let's see, a couple of updated ones. Documentation for hardware recommendations. This came up about a month ago because our current documentation is kind of awful. Nick and I were just talking about that earlier before the call really started. Sage, you had a couple of recommendations in there that I can change. I'll update the transparent huge pages stuff. That I think we wrote that before we officially had the patch in, so we can probably just say that starting with Octopus or Nautilus, depending on how far back I guess we backported that. No changes for transparent huge pages are necessary, but for older versions, you may need to. Let's see.
Yeah, if it only applies to older versions, I wouldn't even mention it. It'll just make the documentation more confusing.
Okay, I'll just take it out then. Let's see. Common options. Increase the default number of RGB bucket shards. This is mine. So I was previously recommending for a very high default number of shards, especially with the changes that we made, which now make it far less impactful on bucket index listings to have many shards. The one case where having lots of bucket shards does still have kind of a linear slowdown is creating new buckets. So if you're creating lots and lots of buckets or deleting buckets, I think more bucket shards kind of linearly impacts the performance of that. Otherwise, the impact on listing is now much better. I think we're going to still default to a lower number than I was initially recommending. And also there's apparently some benefit to using prime numbers here. So 11 is kind of what we've sort of decided on as an initial default. Maybe that changes in the future, but that will at least get us quite a bit more parallelism for a single bucket than we previously were getting. And it's not really clear whether or not we're seeing consistently better performance with higher numbers of shards at this point. We used to, but for some reason we don't now. So anyway, there's that. And then this ARM one, I don't actually remember what was going on with it. I guess Keith, you reviewed it at one point. So, yep, there's that one too. Something about test and perf local on adapting it to the ARM architecture, I guess. No movement on a bunch of other stuff. We talked about the double cache PR. I had a very old PR for doing the actual LRU age binning, which kind of I'm still waiting to get back to and wrap up once we've got the double cache PR implemented. But that will wait for Adam's RocksDB sharding PR first. So I have a bunch of those kinds of things. Let's see what else. Yeah, Adam's sharding PR. Oh, I don't know why this isn't in here. Am I reading the wrong thing? Holy smokes, I just read the entire thing for last month, not this month. Oh well. All right. I'm not going to go through everything all over again because we talked about most of it. But I will mention there's a couple of other new things. That's the only thing I think I'll say here. Split the read IO if the IO size is large. That was a new PR that came in for NVMe device. And then the big one, this is why I remembered I was not doing the right thing. Adam, your objection triumphant. It looks like he's passing tests. But we don't hear you because I think you're muted. But if you can hear me, congratulations.
I said yes.
Anyways. Oh,
yes,
good.
it is.
Well, that's fantastic. When I was looking earlier, it looks like you're just waiting on something from Jason to make sure the RBD looks good.
I just want to have Jason say, yes, this is a good run. And I ran a Ceph run, and there were a whole bunch of failures, and there were a whole bunch of failures, and there were more failures now than the last time I ran it. So I'm actually thinking something screwed up when it ran. I don't know if there was something odd going on in Truthology over the evening or over the night yesterday.
Okay.
But I'll take a look into that.
Are those SE Linux denials because Patrick mentioned something about the FS suite seeing a lot of failures because of that?
Oh, okay. So that's probably it.
Okay.
All right. Two things merged. Kifu's CPP B tree cleanup, which apparently had some performance stuff in there. And then also, oh, sorry, this didn't actually merge. This just got closed by Stalebot. Adam's automation for moving RocksDB files between BlueFS devices. So that was the stuff that's based on Igor's infrastructure that he wrote, if I remember correctly, for migrating SST files from when they land on the block device. If they can be moved back because space has been freed up on the DB device, they can be, if I remember right. I think that was what that was supposed to do. So hopefully he can get that back and working into in a working state so we can get that merged. Okay, yeah, that's it for real. So, all right, should we talk about PG Autoscaler stuff? Oh, unless anyone has any other PR stuff I missed, which is quite possible. All right, let's talk about the autoscaler then. So is Alex, you're here. Alex, do you want to talk about some of the testing you've been doing?
Sure. Can you guys hear me all right?
Yeah.
All right, perfect. So for the last few weeks, I've been testing out Ceph in OpenShift. And with that, I've been observing some anomalies with the default installation of OCS. And those anomalies center around the distribution of data uniformly going to our OSDs. And it looks like the autoscaler is starting off with a small PG count for all of our pools, about 8 PGs per pool by default. And when you have 3 OSDs, that's okay. But some of the cluster that I was setting up had 9 OSDs, and so with the default set with 8 PGs, you can't have a uniform distribution across all 9 OSDs. And so I was seeing how some of those OSDs were getting hit or saturated, and as an autoscaler increased the number of PGs for the pool as capacity increased, we took a performance hit because of the recovery that was going on. But the balancing of that distribution wasn't, say, completely uniform, even after we've gotten to like 35% capacity, we still didn't have a uniform distribution across all of our OSDs. So I played around with the target ratio, setting it to 0.9 before the test began. So that would allocate all PGs to it, or most of the PGs to the pool. And that's when I seen a better distribution of data to those OSDs, but there was still some variance between there. So then that's when I started to play around with the PG balancer. The PG balancer is just more of an active role of balancing those PGs across all the allocated PGs across all the OSDs. And at that point, I seen like a less than 1% deviation between the utilization of the OSDs. So all OSDs were pretty much spot on after I enabled autoscaler with a target ratio of 9 and enabled the PG balancer. From that point, I've been playing around with increasing the PG count and decreasing the PG log count. And there was one anomaly running those tests where when I increased the PG per OSD to 1,000 PGs per OSD, we had a significant reduction of performance. And I just finished last night rerunning that test, and it looks like there was just some kind of hiccup or red herring that happened during the testing of that. But we have a better performance than 100 OSD PGs per OSD using the 1,000 with my retest. We don't have a drop in performance. It's an increase in performance. I don't have the full numbers yet, but I did update some of my slides that I can send out later for you guys.
Excellent.
So it sounds to me like the takeaway from this is just that in the case of your deployment where you know that the pool that you're creating is going to consume the whole cluster eventually, that you just need to set that target ratio.
Sage, why wouldn't we
And I
write
think
the Ceph to do that by default automatically?
because if you create say you create the first pool, and then you wait 20 minutes and then you create the second pool, we don't want the first pool that's going to be empty to use 10,000 PGs, and then you create the second pool and then it has to shrink it down again.
Why not?
Shrinking that first pool later is super cheap, though. If there's nothing in it, there's free, isn't it?
I mean, it takes a long time because it's like a built-in 10-second turnaround per PG, so it'll take hours possibly to I mean, I guess in the smaller clusters it won't take that long, but it'll take longer.
That delay, if there's no data, is there any reason to have a delay like that? Or if there's very
Yeah, I
small
mean,
amount of
that's
data?
the mechanics of the way that the PGs get merged. It does it one PG at a time, and it just isn't fast. So that's. But I mean, I think the other thing is say you create two pools, you have RBD and a SFFS, and they're both empty, and or maybe you write you create one RBD image, so you have 20 megabytes in one pool, and the other one's empty. We don't want the cluster to go and allocate a bazillion PGs for one of them and no PGs for the other, because they're, for all intents and purposes, they're both are empty, right? We just have no idea what space they're going to consume. So that's why it's.
Can I just?
Yeah.
Sorry, it's a real life example. Not with the auto tuning, but I did a PG merge on a older pool, and I think it has an interesting effect when the PG balancing is also on, because stuff just starts moving around everywhere after every merge, as the number of PGs per OSD change. So actually, even though this pool had very little amount of data, the whole process took quite a considerable time until I turned off the PG balancing.
So was that with the pre-populated pool, and then you turn on balancing,
Yeah, it was an
or an
old
empty
pool that I
pool,
had,
and then you?
which was it. It was an old pool which was a replica pool that most of the data has now been copied out to Erasure coded pool. So it probably only had a couple of hundred gig of data on, and this is over about 200 OSDs. But to actually shrink the number of PGs down in that pool, it probably took nearly a week. And I think it was the PG balancing, which was then running after each time, because I'm not sure if the merging waits for the health to go fully okay before it starts the next one. But I think the PG balancing was sort of dragging that process out.
Was it? Yeah, I think the merging is super conservative. So if things are moving around, then I'll slow it down. Was that the map balancing mode or the crush compat mode?
Crush compat.
I mean, I wonder if the balancer should just basically step away until the merging stuff is complete. If there are merges that are pending, then it could just like wait.
So Sage, one of the things I'm still wondering though is whether or not we can avoid having the autoscaler do work until kind of it's more critical if we can adjust the PG log length instead.
So the thing you mentioned in standup, there's a card for it. And basically, that is if the balancer wouldn't reduce the PGs used by one pool until the space is actually needed by another pool. So if you have something that has a number of PGs that's appropriate for 50% of the cluster, but it only has 10% of the data, but then the cluster's only 60% full, there's no reason to reclaim that space, quote unquote, until there's like really pressure. And I think that's fine. We can do that. But that doesn't help on the bottom end where you create a pool that's empty, and the reality is that it's going to fill up most of the cluster. But it starts out with a small number of PGs. And I think that's the only way to really fix that is have a minimum PG count that's higher, which I think we did. I think we increased the initial PG count for pools to be like 32 or something.
The last I heard, it's increased to 16.
16.
16.
16. Okay.
Yeah.
Which means that up to a 16 node cluster, that'll at least spread out, or maybe like an 8 node cluster, it'll spread things out like sort of okay. Either that or the user just we need somebody to tell the system that this pool is going to be the bulk of the cluster, right? It's going to take up most of the space.
What if we were to shrink the PG log length though, and then let you increase that minimum a significant amount, so that you have more headroom in terms of PGs to give other pools that are going to fill up the cluster?
Yeah, I mean, it feels to me like the PG log length is a red herring. Like the OSD should just do that transparently anyway. Like if it has a lot of PGs, then make the log shorter, and if it doesn't have very many, then make them longer or something. Like it feels like that should just be. We shouldn't be like micromanaging that in the context of how we allocate PGs.
Well, the whole reason why we can't have more PGs right now, though, is because of CPU and memory, right? I mean, those are the two big reasons why we don't increase the number. So on the CPU side, okay, that's one discussion, but on the memory side, it's all pretty much dominated by the PG log length.
I mean, it's also reliability. Having more PGs than you need just needlessly spreads out your data and makes it easier to have a like a triple failure or whatever. But yeah, I mean, I think we need to. It seems like the way to solve that is just to make it automatically make the OSD choose the PG log length based on the number of PGs on the OSD.
Counter to your point earlier, though, that also makes recovery take longer. By spreading it out over a larger percentage of the cluster, you can have your more OSDs participating in the recovery of something, right?
Having more PGs makes recovery slower or faster?
It should be faster, right? Because now you're spreading out your recovery over a larger number of devices.
Yeah.
So trade-offs.
Yeah. I mean, I'm fine with increasing the minimum even beyond 16. I mean, if we make it like 32 or maybe 64 might be pushing it, but
I think there was a suggestion in the tracker to make it related to the number of OSDs. Would that make sense?
yeah. But like, if you have 1,000 OSD cluster, does that mean you want 1,000 PGs for a new pool? Like, I don't know that. I don't know that it like works in the limit.
Well, maybe we have a
it
minimum,
depends
but initial
for
value.
data pools.
Say it again.
I was thinking maybe
Well-
not a minimum value, but an initial value. If we were going with this idea that we don't decrease until there's pressure from other pools.
Yeah. Yeah, that might make sense.
There's also one thing on data pools, not metadata, but on loaded pools, that it depends on the workload. For read-intensive workloads, if you have 2 PGs, since we do not balance the primaries, if you have 2 PGs per OSD, then obviously you'll have under heavy read loads, you'll get unbalanced, and some of the devices will choke before the others. So we need to be careful about this.
The reads are also synchronous, right? They're not async, so there's also like a read latency problem when you don't have very many PGs.
We also have lock contention. I see it on reads.
Yeah.
Even
Yeah,
random reads.
that's the same thing. It's the same
Yeah.
thing.
Yeah, exactly.
So Mark, when you say we should be auto-scaling the PG log lengths, how low versus how long do you think we should be going? My argument is, what if we reduce the PG log lengths for everything, like for the default values?
So that's a good question. That's one of the reasons why I wanted Alex to look at this. It seems to me like there's not a whole lot of difference, if we ignore DUBOPs for the moment, between having 100 PGs with 3,000 entries each versus 1,000 PGs with 300 entries each, until you get to the point where the total PG count starts like causing scaling issues for the whole cluster. But that's pretty big, I think.
Yeah, I mean, it seems like the simplest thing we could do is just take, if our rule of thumb is 100 PGs for OSD and the PG log length is 3,000, we should just replace that option with a PG target of 300,000. And then every primary will just divide by the number of PGs and set that as the target, that as the target trim. That isn't exactly precise because some OSDs might be, the replicas don't control the log length, only the primary does. But in general, the primaries and the replicas are going to be managing the same PGs because of the way that the crush rules are set up. And so I think it'll work. It would probably work just fine. And in the extreme, if you have one PG, you'd have like 100,000 log entries or one PPG, but that's probably fine also. Or you could have a cap, I don't know.
Well, that's what I was just going to say is have a cap. Make it like the cap 100 OSD or PGs per OSD per pool. Don't go above that. So you've got headroom. So that, if you create that starting out, then you've still got like 900 PGs per OSD for other pools that you can play with. So you really don't shrink very often. Like you'd have to have lots of pools before you start shrinking, if that makes sense.
Yeah.
That's an easy change to make.
And even like 1,000 PGs per OSD, that might even be kind of arbitrary. We might be able to get away with 3,000 and a length of 100 per PG, possibly. I don't know for sure. We have to look at it.
Yeah, I mean the thing is, when you increase the PG count, then all of the overhead for all the peering and stuff goes way up also. So yeah, I don't think you want that many PGs.
Yep.
I think 100 is still like a good rule of thumb, but I don't know.
Yeah, Access testing also showed some big bottlenecks at the manager level with the PG stats and everything.
Yeah, that's the thing that. Yeah, you're right, Josh.
Could probably use some, like, intervals there maybe, but we can't do that. Make that too slow.
Josh, when I looked at some manager stuff earlier, I was wall clock profiling, I think, when I was seeing like really high usage. If I remember right, I think it was all just like O string stream, like
Yeah, David's
garbage.
Appin's optimizing a bunch of that right now, and that should be
Okay.
a lot bit better. But yeah, I'm not sure if that's purely where all that CPU usage is coming from, or if it would still be pretty high with a high number of PGs, even if we got rid of that JSON transformation interface.
Yeah, I don't know. You're probably right that we should also look at the interval, though, right? Of collecting the stats.
Yeah. And of modules responding to them or analyzing the entire list of PGs.
Yeah.
And to Sage's point and Josh Solomon's point about primaries not being balanced, I think that's also something we want to take a look at too. The up-out balancer in general doesn't consider anything other than number of PGs right now, but it could take into account both primariness and amount of data as well.
On the performance side of that, I'm still not totally convinced that balancing it certainly helps in terms of like reducing skew, right? So you can do that. That's good, but you're still going to have the potential for like an unlucky string of objects hitting like the same OSD in a row, right?
Sure. There's always the possibility that you end up serialized because you got your objects happen to go to the same PG.
Yeah.
Seems.
So I'm not totally sure if it really gets rid of the random clumpiness of I/O. Like it helps get rid of skew, but I don't know that it gets rid of the clumpiness in reality if you're looking at like I/O over time.
In the tests that I've done in the past, it was quite clear that it helped a lot. It was really obvious that it was on magnetic disks, but it was really obvious that when you had more PGs on the device, this device choked first and actually killed the entire system. So I saw it several times.
Josh, was that when you had like a low overall PG count, so that it like I'm wondering, was it more important to was it removing skew, or was it like actually getting rid of a lot of clumpiness in the I/O that was going around?
What I saw with related to the number of PGs, the measure that I took to see how unbalanced the system is that I took the OSD with the largest number of primary PGs, that is primary for the number of PGs, and divided this by the average. So I had a number 1 point something, or which said, so yeah. this something got, and I could find the exact numbers, but approximately every time I doubled the number of the PGs, this X, 1 point X, was divided by 2. So I got half. So if I started by 1.8, I doubled the number of PGs, I got 1.4. That was the number, approximately what I was doing. And I have this from the exact number from the last year's Ceph presentation. I could find them. So, but I started with 1.8. It's a real number. And in 1.8, you really see the system chokes way below the expected performance.
Was there much difference when you have the balancer running versus having a large number of PGs? In that scenario, was the balancer helping versus just having a large, making the distribution more uniform via lots of PGs?
If I remember correctly, and I need to check it, I didn't have the balancer running, but I got to a relatively good balancing without it. But I didn't have a balancer running for me at that version. It's a year ago.
Okay. Okay. Yeah, no worries.
Yeah, for what it's worth, the latest upmap code is always going to try to get to the same number of average PGs per OSD with minimum deviation, which is 5 PGs different. So that in this case should definitely help.
So Niha, that 5, that's a static number?
That's a config value, which was earlier set to
Okay.
1, which is, I think, pretty extreme. So we moved it to 5. So
Okay.
the aim here is that as long as we are 5 apart from what the average PGs per OSD is, the balancer is not going to try anymore.
Okay.
You could always go ahead and change that to like 1 if you want to get to that extreme balance.
Which again, for small system, 5 is pretty high number. Like if you have
Right. So
32
that's
PGs, it's really high.
right. But we didn't want to make an extreme config option for an average user, right? A small cluster is not what a user would usually run. We have a way for you to change that, so you can always go ahead and change that to 1, and you can get an extremely balanced system.
But what I would do would just use the percentage instead of static number. But that's okay. It can be changed. It's okay.
On a setup where you have, well, okay, yeah. I was gonna say where you have a very small number of PGs overall, you may then have trouble hitting a percentage target, but might not matter. It's much easier to hit that when you've got lots of PGs, right?
It's also done on a per pool basis, so when even with large clusters with lots of PGs, you may have some pools with only 8, for example, like some metadata pool that doesn't need a lot of parallelism.
Yeah, yeah. It'd never be able to do it.
Right.
What happens in that case right now if you're trying to get within like 5 PGs and you've got some OSDs that have no PGs at all? What does the balancer do?
I think at that point it stops continue to try. But if you reduce that threshold down to below where it can reach, I think it will continue trying to see if it can find a better solution and then bail out when it can't. But it essentially wastes a bunch of CPU in the manager.
Yeah, and if you don't want to do that, there is a tool for you to try these out. So you can just give a number like 5 and see how much time the optimization is going to take, or is it even completing in the amount of time you need to complete, and then you can apply that configuration to your system. So there's a way to try it out.
All right. So it sounds like at the very least we've agreed that we should make it so that we're not prematurely shrinking stuff, right, Sage? I think we want that at the very least. Do we want to keep looking into whether or not we can do a semi-modest shrinking of the PG log length and simultaneous increase in number of PGs? Is that worth continuing to pursue?
I wouldn't put it that way. I think it's two things. It's making the primaries decide the PG log length based on the number of PGs. That's one thing. And then the other thing is increasing the minimum or the default PG count per pool.
One thing I want to add to that, Sage, Josh and I were at one point talking about allowing PG log length to vary per pool.
Sure. I guess if we do the thing where the OSD just looks at its number of PGs and divides, then if you have two pools that are mapped to the same OSDs, then they'll get the same PG log length. If you have two pools mapped to different OSDs, then they'll end up with different PG log lengths based on how many PGs are allocated for those devices. So you'll sort of get it anyway, and it'll be controlled, still be controlled by the amount of memory basically that you want to devote to OSDs. I'm not sure how important it is that you say like, I want this pool to get twice as many PG log entries as that pool. Something, I don't know if that really makes sense or not.
Yeah, I can't remember that discussion. What our reasoning was.
Sage, exactly what you just said is exactly where I want to go with this, though, is we decide how much memory on the OSD we want to devote to PG log, right. And then we have several different knobs that we can tweak to get there, potentially without invoking the balancer.
But is it important to prioritize different pools? Like, assuming that I'm going to spend 50 megs on PG logs or something, do you want to say like this pool gets more logs than this one?
So do you remember earlier we were talking about how, okay, you devoted a certain number of PGs up front to a pool, and then what happens if like that was way too many and you have to shrink it now because you want to give PGs to another pool, right? Mm-hmm. This could be one way that you could allow the memory usage for that OSD to shrink without actually shrinking the number of PGs for that pool. You could just shrink the PG log length of the PGs in that pool so that now other pools can get more. It's the same effect as reducing the number of PGs in terms of the overall amount of log data that you're allowed to gather for it.
It's the same effect on memory, but all the other stuff is still, I mean, we still want to reduce the PGs for all the other reasons, right?
Sorry, I meant the same effect on recovery, right? Because you have the same total number of PG log entries for that pool. By shrinking the PGs, you're doing that implicitly. Here, you're just doing it explicitly.
Yeah. But it's like, I mean, the amount of memory used by PG logs is just one factor out of a bunch, right? Like there's all the peering overhead, there's the data reliability, there's, I don't know, whatever else, right? So, yeah. So
I think we hit it first.
I think we shouldn't get too focused on just the memory because we'll end up engineering a solution just to like optimize the memory part and ignore all the other stuff. When if we just tune the number of PGs, then we get everything, right? Everything sort of falls out of that.
I don't necessarily. So I don't necessarily agree with that, I guess, because it's so like the memory during or the CPU usage during peering. I don't think we actually hit that until a much later level than we hit memory. Memory is kind of the first thing that we notice by increasing the PG count because 1,000 PG entries per OSD can be like 2 gigs of memory right now if you have like really big object names.
Yeah. I guess I just don't want to make something complicated when something simple will solve the same set of problems. And it seems to me that the problem that you're concerned about is you have too many PGs in one pool and you need to like quickly adjust to that. And if you just scale down the number of PGs without like the other scaler already does, then the problem will get solved. It'll just take, a couple hours for it to do it, but do it.
What I don't like about it though is that you have to have all this coordination and overhead on the cluster to be able to actually do that versus when you're adjusting the PG log length that's local to the OSD and it doesn't involve any kind of like data migration or changes,
it just involves writing more code because you have to then have another knob that's associated with every pool of what the extra weighting factor for how much PG logging it gets, and it complicates the things. I'm just wondering if there's like a real use case where that actually is important or not. Or if we just do the simple thing where we take the number of PGs and divide that into the total budget and then walk away. Like that should just work.
If we can increase the number of PGs, at least then just using the autoscaler, we could avoid doing a lot of like growing and shrinking because that gives us enough headroom that we can maybe have a reasonable default number of pools without doing any kind of growth or shrinking, right? You could avoid it until much later on.
I have to start over, but I didn't really follow.
So if we even so to your point, we could, if we just use the PG autoscaler, but we increase the number of PGs while shrinking the PG log length, that at least would give us enough headroom that we could maybe avoid doing a lot of that autoscaling work until later. That would at least buy us that, which is, I think, a big win.
And the autoscaler is pretty conservative, right? It only makes a change if it's off by 3x. Maybe it should be. So it isn't gonna waste time.
So I guess the question I'm concerned about is how can we make a cluster perform well out of the box when it's initially created?
And just increasing the default number of PGs beyond 16 probably will get us most of the way there. Unless unless the cluster is really big.
The scalar so that doesn't immediately decrease it, right? So we can stay there.
Yeah.
At that initial high number. Seems like that.
So if we did that, the don't decrease unless there's pressure, and automatically select the PG log length based on the number of PGs. Like if we did those two things, and then 3, we just increase the default number of PGs.
Mm-hmm.
Like it seems like that would cover just about everything.
If we can, if like so the worst case, right, is where you're doing like a bulk fill of a new pool that is small to start out with, and then like grows really quickly, like on NVMe, and you're adjusting the PG count as you're filling it. That's like the kind of the worst case scenario.
That's worst case, yeah. Yep. And basically in the limit, what that works out to is the data will move twice. You'll write it in one place, and then you'll move it again. And that's the price of not telling the cluster anything about what you're doing, right? If you tell the cluster, like, I created this pool and it's gonna be 100% of the cluster, you just do that, then you don't have to pay that price. So it's really only the and I mean, and to be clear, like OCS operator or whatever, like in this Kubernetes case that this all started from, like it knows that, right? It could just say 50% it has a pool for block and a pool for file, or whatever it is, right? It can just say 50-50, and that's going to be fine. And then this will never come up.
I guess I'm not convinced that we need it to be this way, though. I think it's only this way because we've engineered it kind of to be this way.
It's this way because we don't want to have too many PGs. Yeah. If we just said that all pools had like 100 PGs minimum, or 1,000, or every pool had enough PGs to like fully saturate the whole cluster all the time, then this problem wouldn't be there, but the cluster would be less reliable and it would be slower, and peering wouldn't work as well, and the manager would use way more CPU. The other stuff would happen.
Alex's results, at least in the case where we're not peering, separate thing, showed it was faster.
Yeah. But in all other cases, that's not the case. Like peering is slower, recovery is slower because there's more PGs doing all this stuff. I think the most important thing is that your data is less safe because you have a small data set spread across way more devices than it needs to be spread across, which means that concurrent failures are more likely to take out a part of your data. That's the one that I lose sleep over, and I don't want to
Yeah. I agree with that. I disagree that it's slower because we just earlier established that when you have more OSDs participating in recovery is faster.
Yeah, but if you just tell the system how much, if that's the big data set, then it's the same. It's the other stuff, right? It's not just I/O. It's peering, recovery, the manager, CPU that the manager uses, PGLS, like all the other stuff. You just have way more PGs than you need, and everything is inefficient as a result, except for the I/O path, but everything else.
Certainly the manager. I'll get behind you on that.
Yeah.
I mean, I think it's
There's
important to
probably even
remember that we want to optimize for the typical case of the users, not for what we're doing when we're running our tests. So, like, if you have a big cluster and it's mostly full of data, and the balance between the pools changes over time, we'll keep up with that. Like the balancer handles that. The data distribution changes slowly, and it changes the PG count slowly, and that happens automatically. And you don't notice. If you turn on a cluster that isn't of trivial size, and it has nothing in it, and you don't tell it what it's going to get, and then you immediately fill it as quickly as you can, like one-dimensionally, then it's true we're not as fast as we could be there, but that's because we had to choose between being fast for someone running a test and not telling the cluster what the test would look like, and between being safe and fast for our users. And
I
we
think
chose to
that's
be safe and
perfectly
fast for our
technically
users, not
correct.
for our performance benchmarkers.
But it's not a purely technical decision, right? You also want to have Ceph behave in a way that users who are new to it see it perform its best. So I think we're kind of talking about like the long-run behavior. I think makes sense right now with the way we have things set up now with the autoscaler adjusting things slowly over time. We want to make sure the initial behavior doesn't make Ceph look bad, right?
But I think we can do that. I think we can do a pretty good job if we just have a reasonable minimum number of PGs, initial number of PGs. Then fine. Like even if you deploy a 1,000-node cluster, create a new pool, and you don't tell it anything else, you're going to spread that IO over across. What if the default PG is 32? You're spreading that IO over 96, whatever 32 times 3 is, 96 disks. Like you're going to get pretty good performance. You're not going to get 1,000 OSTs worth of performance, but you're going to get good performance. You're probably not going to be able to saturate that from the client side. And I think at some point, if you're deploying something that's really big, like you can give it a hint. It says, by the way, like, I mean, if we document this properly, if the dashboard, when you create a pool, it's like right there, and it says like, do you know what portion of the cluster this is going to take up? It won't be on the CLI if you like already know the CLI command, but the documentation that says this is a CLI command can say, by the way, you should also run this command that tells you what your default or expected usage is. So.
Paige, I kind of fundamentally disagree with pushing things onto the user like this because it complicates the UI, it complicates the documentation. It's more stuff.
Yes. I know you can't.
So we can
right?
We can come up with simple things that capture most of these use cases that don't involve us building massive new systems into the way Rados operates, right?
I don't think we need to do that. Like
well, you just talked about like 4 things you want to do that have major impacts on like the way the cluster, not like the literal code, but on the way the cluster operates and our knowledge of and like the lifetime of the knowledge we've built up. And so yes, we need to come up with simpler things that work for most of these use cases. And one of them is
we're talking about with initial conditions are relatively simple changes already, right? Just changing a default number, that's a very simple change.
Exactly. I think we're overthinking this. We already have a solution for a big system or a large scale cluster. We don't need to over optimize for the initial case or an amateur user or a performance testing use case. What Sage said, I think, is enough to handle that. And I mean, it's more like knowledge, right? The more the PG autoscaler is going to be used, people will know that they should know what their pool size is going to be, and they'll probably start using the target ratio already. And when they are not using it, we should just increase the basic PG count and stuff to handle the out-of-the-box experience for them.
Yeah, I would agree. I mean, most users, if they've already made a decision when they've purchased the hardware for their cluster about what they're going to be using it for. So if you buy a cluster, you've worked out you need so many terabytes, and you probably know it might be for dataset 1, dataset 2. What they probably need help with is turning that into a number of PGs.
Yeah, and that problem we solved, right? They just need to say this is going to be half the cluster and this is going to be a third of the cluster.
Yeah.
Yep. In the absence of that information, we have to guess. So we can guess that the user is going to be somebody's running a benchmark and we want to give them the biggest number possible, or we can guess that that user is a casual user and whatever. But we have to guess, and we just have to pick something middle of the road for that. So that's what we're doing.
So let's start out by at least just doing the thing that we talked about that we agreed on, right? That's a fairly easy change. The make it so that we don't shrink when we.
I think there are three things. Yeah. Don't shrink unless there's pressure. Pick the PG log length based on an overall budget per OSD and the number of PGs instead of having it fixed per PG. And then increase the default or the initial PG count per pool. I think if we do those three things, that feels like a pretty good middle of the road.
So who's going to work on this?
Ticket's been sitting in the tracker for forever.
Yeah.
We can maybe talk about that later, Mark, but I think we have three clear things to do now, so that's good.
Yeah.
All right. Well, we're almost at the end of the hour, so anything else, guys? All right. Well then.
Not for me.
Have a good one, and we'll reconvene next week. See you later.
All right.
Thanks.
See you guys.
Thanks.
Bye bye.